Okay, so here we go. Rational functions and zeros. Okay, so please, 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 please keep trying to get everybody to remember that there are several other names for zeros, and you need to keep that in your head. We are talking about x-intercepts, right? Which is also basically solutions and roots. Okay, those are interchangeable. Now, the only one where you can just write it as an x equals a number is a solution, but those all mean the same thing, and you need to get used to being asked for all four of those things and realizing they mean the same thing. Okay, so let's go ahead and go over a couple things. All right, so the function, that is basically the rational, which is a division of two polynomials, has zeros when g of x equals 0. Okay, so basically you're only looking at the top of the fraction, right? The bottom of the fraction tells us other things that we're going to get to. And yes, definitely the function is undefined when the denominator equals 0, and we'll be getting into that more when we start solving and finding vertical asymptotes and all that. But the big thing on this means that you only need to factor and solve the numerator to find your roots, zeros, x-intercepts, solutions, however you want to put it. So you only have to worry about the numerator, which is kind of nice. It saves a little bit of work. Okay. Yeah, so when we start solving, then we're going to have to basically find the zeros and what we call the undefined values, because if you solve an equation and you get an answer that's not allowed, then you actually have to state that that answer is not allowed. And it is possible with rational functions quite frequently. Okay, so when you're solving rational inequalities, right, when we get to that, you're going to need to make sure it equals 0, like normal when you were solving polynomial inequalities, when we were trying to figure out where they were positive, where they were negative, all that kind of thing. It does have to equal 0 on one side. It's kind of a requirement. Yeah, and make sure you only have a single rational function. You cannot have any extra pieces. Very similar to things like absolute value, square root functions, any kind of radical functions. They kind of have to be by themselves on one side before you can actually mess with them. Yeah, so we take the bottom and we set it equal to 0. This gives us our excluded values right here, right? And then setting the top equal to 0 and solving it gets us our x-intercepts or our roots, that kind of thing. And when we do the sign chart, like we did on the polynomials, we have to include both of those, okay? Because those excluded values are going to cause some very interesting things to happen. And yes, make sure you factor. Okay. Right. And again, very specific reason why we include those, because we're never allowed to include those in the solution. And you'll see that when we start writing the answers. It's going to make our answers a little bit interesting, because you may have, multiple pieces that are your answer because of those, basically like an interruption in what you have for your interval. Okay, so same thing that we did with polynomials. You are going to test values, in every interval between your pieces to see if they are positive or negative, right? And then you will see where your answers are going to be, because again, if you have something that's greater than, you're obviously looking for those that are positive. And if you have a less than, then you are looking for those that are negative. So you got to make sure you're paying attention to your inequality sign. And we definitely need to talk about interval notation and think about where the ends of our graph are going, which goes back to 1.7 when we were dealing with end behavior. Okay, so first off, let's go ahead and find the no-no values. And it's already been factored for you, so it makes it a little bit easier for the first one. X plus 6 equals 0 and x minus 3 equals 0. So that basically means that x cannot equal negative 6 and x cannot equal 3, right? Because if I put either one of those in the bottom, you'd get 0. No zeros on the bottom of a fraction. That's a no. Okay, the top one is just a normal, so these are my excluded values. Okay, so x minus 2 equals 0. That means x has got to equal 2. So these are the three numbers I need to put on my number line, just again like we did for polynomials. So I'm going to put negative 6 down here, and then 5, 4, 3, 2, 1, 0. 1, 2, 3, 4, just so I can get above where I need to be. Now remember, you have to pick numbers that are on between each of these and like every single other, you know, outside them as well. Again, we did this for polynomials. It's the same concept. So I'm going to go ahead and go with -7. I'm going to stick with the 0 because it is between those two numbers, and 0 is the easiest one to deal with. Unfortunately for me, I have to pick a number that is between 2 and 3. So 2.5. And then I have to pick a number above 3, so I'm just going to pick 4. Okay? And remember, this is not included, and neither is this. So when we actually write our answers, those are not included, period. So at this point, all we're doing is just plugging in to see what we're going to get, if it's going to be a positive or negative answer. Okay, so pause if you need to, but bear with me. I don't have my calculator, so we're doing this by hand. So -7 minus 2 is -9. So -9. -7 plus is -1 times -10, which would be 10. So -9 over 10 is just going to be a negative number. Oh, different color. Negative number. There we go. So no, we already know -6 is not included. So now the next number I'm going to check is going to be 0, right? Because the numbers I got to check are, or the numbers I got to check between and outside of are -6, 2, and 3. All right, so 0. 0 minus 2 is -2. 0 plus 6 is 6. 6 times -3 is -18. So -2 over -18 is going to be a positive. Okay? And again, bear with me because I know the next one's going to be horrendous as far as the fractions and whatever else. But well, all I'm interested in is whether it's positive or negative. So, okay, so 2.5 minus 2, that's 0.5. And then 2.5 plus 6 is going to be 8.5. And then 2.5 minus 3 is going to be -0.5. So I don't actually have to multiply this out to know that this answer is going to be negative, because I've got a positive top and a negative bottom. So that means that is going to be negative. All right, so substituting in 4. 4 minus 2 is 2. Okay, and then 4 plus 6 is 10. 4 minus 3 is 1. So this one is going to be positive. Okay, so we need to figure out where our answers are, so we know basically where everything's going to be. Okay, so we also need to know what the end behavior of this is. Okay, so this is bottom heavy, right? Because you've got an x squared on the bottom and an x on the top. So it's bottom heavy. And if it's bottom heavy, then my horizontal asymptote is y equals 0, right? Okay, so as I'm basically going out to infinity, right? My graph is going towards 0. Okay, my inequality says I need to be greater than 0, greater than or equal to 0. So that means I'm looking for my positives. Okay, well, it's positive between -6 and 2, right? And then it's positive again when it gets above 3. But I'm not allowed to include 6. So we know a notation for that with interval notation. If I'm not allowed to include 6, then I write it like -6 to 2. And from 3, because am I allowed to include 3? Or is 3 one of my no-nos? Nope, 3 is one of my no-nos. I can't include that one either. So that would be 3 to infinity. And that's how we write the interval notation for that. So not included means you're just going to be putting a regular parentheses instead of a bracket. Okay, so let's try another one. Again, these take a little bit of time. I get that, and we will have plenty of time in class to work on them. Okay, so x squared minus 4 becomes x plus 2x minus 2. Hopefully everybody remembers that is a difference of squares. The bottom is 3 pieces, so product and sum. What multiplies to give you negative, or positive 25 adds to give you -10, should be x minus 5 times x minus 5. Okay, so the only thing that's a no-no is where our exempteds is 5. So x cannot equal positive 5. I can set both of these equal to 0, should be pretty easy, and find out what I'm checking. And that would be 2 and -2. Okay, so again, number line. I have to go all the way to -2. So -2, -1, 0, 1, 2, 3, 4, 5, and then beyond because I actually have to check. Okay, so again, just a mark for yourself. And this is the way I just keep it in my head. Not included. That should be NI, not NE, but you get the point. 5 is not included, so wherever I'm looking for my answers, I have to make sure that I cut off at 5. Okay, so these are my x-intercepts. So I need, again, numbers on both sides. -3, 0 is already there, so I'm good to go. How about +3 and just +6? Again, plug and chug. And I'm going to plug it into the factored version only because it's a little bit easier for me to deal with. You can do it in either one. It doesn't matter. All right, so -3 squared, please remember, is positive number, right? Because you square a negative, you get a positive. Okay, and 9 minus 4 is going to be 5. And then on the bottom, -3 minus 5 is -8. So basically, -8 times -8. So 5 over 64 is going to be positive. And again, I'm only interested if it's positive or negative, not what the actual value is. All right, so 0, since again, that's between -2 and 2. Substitute in 0. 0 squared is obviously 0 over -4. And then I'm going to end up multiplying -5 times -5. That's -4 over 25. That is a negative. All right, substituting in 3. 3 squared minus... 3 squared minus 4 is still going to be 5. Had a moment. And then 3 minus 5, -2 times -2. That is going to be a positive. And then 6. 6 squared, 36 minus 4 is 32. And then 1 and 1, that is also going to be a positive, which is possible because we have that. Basically, that's going to end up being an asymptote, a vertical asymptote in the middle. Okay, so I am interested again where the graph is less than 0. And by the way, this is balanced, and that means that my horizontal asymptote is at 1. Okay, so as far as the ends going out, it's not a slant that I have to worry about. Okay, so I'm interested in where it is negative. Okay, so it is negative between -2 and 2. That's it. Okay, and because those are both included in my answers, right? They're not part of my no-nos. The answer is literally just -2 to 2. And that's it. All right, let's try a couple more just to make sure you're good. Okay, so same thing. When here, you notice it's, being given the same problem. It's just other kinds of problems. And that's all you'll be told is just to solve. Okay, so the good news on this one is your excluded value is 3. And you don't have any x-intercepts except for basically 0, right? Because there's no x's on top. Okay, so that means a very short number line. The only thing I'm doing is I have my no number, not included, and I have to pick something on this side, make it easy, and something on this side. Okay, if I substitute in 0 for x, I'm going to get 2 over -3, so that's a negative answer. If I substitute in 5, I'm going to get a positive answer. That's it. And I'm only interested in the numbers that are greater than 0, so the positive ones, right? So basically, my 3 is not included, right? So that just means parenthesis, not bracket, and I'm going to infinity. There's only one break in the whole graph. So nothing on top to factor makes life a little bit easier. Okay, so excluded values, x cannot equal -5. And then solving the top by setting it equal to 0, right? Should be -8 divided by 4 should be -2. Okay, so again, -5, 4, 3, 2. All right, so I'm going to pick -6 and 0. And then I have to pick one in between. How about -4? Right, somewhere in between them. All right, so again, it's plug and chug. Tell me whether it's positive or negative. So again, pause it if you need to. -6, it's -24 plus 18. So that's going to be a negative number over a negative number. So that means that that answer or that side is going to be positive. And again, I'm not going through the numbers because all I care about is if it's positive or negative. So I can do that again, just in case I lost you a little bit on that one. I'm only interested in the signs of them because I know negative over negative is positive. So if I substitute in -6, that's -24 plus 8. That's going to be a negative number. And then -6 plus 5 is also going to be a negative number. So negative over negative is positive. All right. -4. Okay, so that's -16 plus 8. That's going to be a negative number over a -4 plus 5 is a positive. So that is going to be a negative. And then 0, that's going to be a positive number over a positive number. So that is going to be a positive over there. Again, that's all I'm interested in is whether they're positive or negative. Okay, my inequality tells me I want all the things that are negative. Okay, and the only number that is not included is -5. However, oh, never mind. And beyond -5 doesn't actually count because it's positive. Okay, so -5 to -2. Sorry, a -2 is included. So that gets a bracket instead of a parentheses. If you think about it like this, since -5 is not included, I can get everything up to, but not getting that number. And then the -2 is included. So same concept as writing it as an inequality for there. Okay, so we'll do the other couple more in class. I want to make sure you're good. We'll go over that as a class just to make sure. Okay, so now if we have one graphed, we hopefully should be able to write the inequalities or the intervals depending on what they want. And we've seen this before, again, with polynomials, as far as where they're positive and where they're negative. Okay, so where is the graph less than or equal to 0? Okay, so less than or equal to 0 would be this chunk right here, because we all do actually include the 0, so that means we're going to have a bracket, not a parentheses, and this chunk right here. Now, here's the thing. What you need to understand that those are vertical asymptotes that you can't go past. Okay, so it's very, very similar to what you were seeing up there where you're going to have like, those are the no-no values. You're going to stop there. So this one is actually less than less than or equal to 0 between -3 and -1, like that. And then the other side starts at 2 and can include 2 because we have an equal to 0, and then stops at the other no-no piece, that vertical asymptote that you can't cross. Okay, so now we're going to get a whole bunch of regular parentheses, not brackets, because this one says strictly greater than 0. All right, pick a different color, strictly greater than 0. Well, we know this whole thing is. We know this whole thing is positive. The other part that's strictly greater than 0 is between here and here. Okay, and that's the middle piece. We do the intervals from left to right. Okay, so because of the horizontal asymptote, I know that this is going to stay right or near 1 all the way to -infinity. So -infinity to that first no-no position, which would be -3. Okay, and then you're also going to get that middle piece from -1 to 2, again with parentheses, not brackets, because it's not included. And then the last piece is going to be from 3 to infinity. Okay, now you'll notice that the only thing that would save this, right? The only thing that would make this change is if I had an equal to, like greater than or equal to 0, and then this middle one would have brackets. The other two would still only have parentheses because you're not allowed to actually equal that -3 and +3. Okay, so now I want just the ones that are greater than or equal to 1. So that leaves out that entire bottom half. It's below that horizontal asymptote. So now I'm only including those two at the top, which means it's from -infinity to -3, and then 3 to infinity. Okay, I will see you tomorrow.